All right, scientific notation is a great way to recognize significant figures because that's all they show. So what's important about this idea of showing significant figures quickly is that only one significant figure is in front of the decimal. And then you'll have some power of 10 to show you how large or small that number is, virtually erasing any kind of leading zero that you might mistake for a significant kind of zero. So as we look at scientific notation, notice that they just use powers of 10. We saw powers of 10 briefly with the acid-base chapter already. Mostly we saw very negative exponents, which means very small numbers. We were using that 10 to the negative 7 as a reference for neutral in that pH scale. So just remember that the bigger the power of 10, the larger the number. But also the bigger the negative number, the smaller that value would be if those negative numbers are exponents. So as we look at some numbers and think about how to put them into scientific notation, just remember it's like skipping a rock. So if you have a 4.68 and you want to convert it to scientific, from scientific notation back to its normal number, know that your calculator can also do that by switching the modes and DRG. In this case, it's a -1 for letter A, so we're going to make it smaller by moving to the left one position. So we would get a 0.468 as a result. So notice we moved to the left because that was a negative exponent. We needed to make that number smaller than it is represented in scientific notation. Let's try another one. We have 3.19. This says to the -2. So now instead of one space, we're going to go 1, 2 spaces to add a decimal. And now we get 0.0319. And here we have a larger number, so we're going to go, in this case, we go 4.7325. Positive 4 powers, so +1, +2, +3, +4. So we're going to end up with 47,325. So notice in these situations we made small numbers based on their negative exponents, and we made big numbers based on their positive exponents. You may have noticed on one example already that we went beyond the numbers. When we go beyond the numbers, we have to add zeros. Those zeros would have been leading zeros. They would have led us to the decimal, whether big or small. And that's the beauty of scientific notation, is those zeros are oftentimes, ignored in scientific notation. So let's try a couple more of these. So here we have a 4.400. And then notice they want us to go to the -6. -6 would be back on -1, -2, -3, -4, -5, -6. So to do that, we need to add a bunch of zeros into those positions. You can add a 0 out front as well. It doesn't really change the answer. So we're moving the decimal from here to all the way over here. 6 spaces, making us a very small number. Here we have a 2.35. And notice they say to the -3. So if we're going to go to the -3, we want to go back -1, -2, -3. So put the decimal there, take it away from there, add some zeros. And then lastly, we have kind of a large number. So we have 6.0. Let's move it over here to give us some room. Now we're moving it to the positive 3 powers. So we're going to go in the opposite direction. Power of 1, power of 2, power of 3. So move our decimal there. It was there. 0, 0. So now we have 6,000. And that's what we show is a bunch of zeros. Notice in letter C, we did have a trailing 0. We wanted to make sure that it was counted, so we underlined it to make sure it wasn't lost in translation. We wanted to make sure we kept the same amount of uncertainty. As we look at scientific notation, just realize that if we're going to put it into scientific notation, we're going to be going the opposite. So you can imagine that we were moving to the left to make numbers small, we were moving to the right to make numbers big. Now that's going to be in reverse. So as we look at these numbers and we put them into scientific notation, notice we're going to be moving that decimal place from its current location, in this case 1 space, 2 spaces, so 1.23 times 10 to the power of those 2 spaces. We need to go behind the first significant figure either way. So here we're going to go -1, -2, -3, -4, -5 times 10 to the -5. Here we have -1, -2, -3, -4, -5 again, but now we have a trailing 0, so now we have 6.0 times 10 to the -5. And then over here we have a large number, so we're going to go to the left, 1 space, 2 space, 3 spaces. So now we're going to have 1.002, keep the last 0 because it was trailing, times 10 to that 3rd space. And that's what we wanted. So it may be possible to lose zeros, but if those zeros are lost, remember those would be leading zeros, not trailing zeros. Sometimes we want to keep numbers that are certain available in a list of zeros, so remember you underline those. If it happens to be at the ones place, you could also put a decimal there. But again, those are very rare scenarios, probably ones we probably won't see too much in intro chem standards by any means. So just remember, as you go to small numbers, notice what we're doing is you're going back. -1, -2, -3, -4, -5, -6, -7. So that shows us we're a teeny tiny kind of number. Whereas if we're a big number, we're going to have a big exponent. So here we're going 3 spaces, and then 6 spaces, and then 9 spaces, and then 10, and then 11. And that's where we see that for a very large number. So big numbers are far distances from the decimal. Positive numbers make huge numbers. Big negative numbers make teeny tiny small numbers. The reason we care about significant figures specifically is when we have to use them in more complicated problems like the next 3 weeks. So as we look at significant figures with multiplication and division, we want to make sure that we maintain the fewest significant figures of the numbers multiplied or divided. So if we have 2 significant figures and we're dividing by 1, notice we keep 1. If we take a number with 2 significant figures and we divide it by, or multiply it either way by 2 significant figures, notice we keep 2 significant figures. So we always go with what's fewest, or what's fewest. That's different than if we're adding and subtracting. If we're adding and subtracting, what really matters here is not significant figures at all. What matters here is really just when does the number run out. If the number runs out at the ones place, so should your answer. Everything else determines rounding. And that's going to happen in your calculator. Your calculator screen is going to be full of numbers. We need to know when to stop that answer. if we multiply a few numbers or divide a few numbers or add or subtract, we need to know when to stop. And if it's multiplication and division, it goes by fewest significant figures. But if it's addition and subtraction, we go by the fewest number of decimal places. And that's where we stop our answer, regardless of any kind of significant figures that may or may not be in those numbers. So let's try some multiplication and division first. So as we look at these numbers, we should recognize a few things. And that's that this is division, so we have 3 significant figures. We're dividing by 2 significant figures because that's a trailing 0. We're going to get inches per hour, and those are going to be compounded. They can't cancel because they're different. Since we have 3 versus 2, 2 wins. So whatever answer we're going to get here, we're going to make sure that it only has 2 significant figures. Because 3 versus 2, 2 wins. Fewest wins. Same idea here. We have 3 versus 2. Whatever we get here also needs to be 2 significant figures again. Because 3 versus 2, 2 wins. We also get miles times miles, and that's going to be miles compounded, so miles squared. In letter C, we only have 1 unit, so that's just hours. And we only have 2 significant figures. The number 3 is an exact number. It's not a measured number. It has no units, so it doesn't have any bearing on significant figure rules. So if we start with 2, we better end with 2 significant figures in this one as well. So when we type them into our calculators, we're going to get 2. So 27.5 divided by 2, we're going to round to 14. 22 times 2 is going to give you 44, which your calculator is going to come out with fine, miles squared. And then because 220 has 2 significant figures, so does 660. Both have a leading 0, so both have a 0 that doesn't really matter other than it shows its large size. As we look at addition subtraction kinds of values, remember to line things up and see when those numbers run out. So if you have a 1555 and you're adding a 0.001 and you're adding a 0.2, notice when we add those up, 1555.201. So based on that number, we're going to stop our answer where the number stops, and that's going to be at that ones place. We have no idea what these numbers are. And so we don't know what those numbers are, we don't really have a good handle on how accurate that answer is. So we're just going to use it for rounding, and that would keep the entire number. But if that 0.2 suddenly became a 0.8, if this is now a 0.8, this is now a 0.8, and now we would round to 1556. So sometimes those numbers can round up just by coincidence, and that would be the case for letter B. As you look at the lower choices, we have 142. We're subtracting 0.48. And when we do that, we're going to worry about where those numbers run out. And that's, again, the ones place for this example. So in this situation, when we get our answer of 141.52, what's really going to happen is this 5 is going to round back up. And if this 5 rounds back up, the answer is still 142. However, if in letter D we had zeros there, then this position doesn't matter anymore, and now our hundredths place does. And if that's the case, then we can keep the entire answer. So you have to pay attention to when does the number run out? Because in addition and subtraction, when the number runs out, your answer should run out in the same decimal position. So we go by fewest decimals, not by fewest significant figures. What if we have a more complicated problem? If we have a more complicated problem, then order of operations comes into effect. So we worry about parentheses and exponents first, but then multiplication, division. Multiplication and division shows us that fewest significant figures is what we're after. So remember here we're fewest significant figures. If we have to do addition subtraction, that would be by fewest decimals. And that rule gets over trumped with multiplication and division rules. So as we look at this number, this calculation at the bottom, this number here has 3 significant figures. This one has 2. This one has 3. And this one has a trickier, all 3. Those are 2 trailing zeros. So what this really shows us is that the division and the multiplication. So specifically the multiplication here is going to be winning PEMDAS. So all other operations are irrelevant. We need to go by fewest significant figures, and that happens to be 2. So one of the risks that you run into is you might start applying all these rules just because you learned them. So you might apply that 20.5 and 15 makes 35.5, and you go ahead and round because rounding's pretty easy to do. And when you multiply the bottom, you get 2.45 because you're just multiplying by 1. The disadvantage of rounding too early and too often is you're going to get further and further away. So avoid doing that, and if you avoid doing that, you still get 35.5, but you can't forget that the number that you use was based on 2 significant figures. So even though that you have 3 divided by 3 in this slide, it was really based on that 15 that we had added on the previous slide, and that's where we need to stop our answer. So our calculator spits out this gigantic number, and that's what it oftentimes will do. There's no choice, A, B, C, or D, that's going to look like that ever. But what is important is the answer is there. We just need to know how to trim it down. So if we're looking for 2 significant figures, we're going to look for the first 2 and then use everything else for rounding. So in this case, we're rounding based on a 4, so 14 stays 14 as an answer. The disadvantage in your homework is there could be a 14.5 or 14.4897, whatever. A lot of the answers could be the same, but to the wrong amount of significance, and that's what this chapter is trying to teach you, to prepare you for getting answers with the same amount of significance as what you start with. And then in a separate video, we're going to show you about units because you can't have a measurement without having units. And sometimes that takes a conversion. So we'll catch that in a separate video.